So in this session, we'll study a little more about musical scales. Now, equally tempered is a scale which we have already studied. And now in this particular session, we'll see how 22 Shruti scale is evolved. How does it come up? That is what we are going to study. Also, chromatic diatonic scale is basically a subset of 22 Shruti scale. So once we understand this, this follows. All right. So let us start. Now, as I said, equally tempered scale is something that we already know. And there, if you consider two consecutive notes, the ratio of the higher frequency to the lower frequency is always constant. That is 2 raised to 1 by 12. Now, if you consider 22 Shruti scale, which we will study shortly, the ratio of frequencies of consecutive notes is not constant. However, this scale sounds better. Chromatic diatonic is going to be a subset of 22 Shrutis, so that also we will touch upon. Now, it's important to note that for scales other than equally tempered scale, the design of keyboard becomes restrictive. Why that is so? Because the ratio of the consecutive notes, the ratio of the frequencies of the consecutive notes is not constant. Therefore, if you design a keyboard for these scales, then your reference note is necessarily fixed in position. So every instrument will have to be tailor-made. Of course, if you build a electronic synthesizer, then it will be easier to do it for 22 Shruti as well. However, for physical instruments, it will be very difficult to build an instrument which works in any key. In fact, it's not possible. So that is the difficulty, and that is the reason why the equally tempered scale is so widely used. However, 22 Shrutis are something that Indian classical musicians often use. So its study is important, and we'll see how this scale arises. So let us study the evolution of the musical scale. Now, Pythagoras was the first one to show that the frequency ratios of small integers sound good to the ear. For example, take these ratios 2 by 1. 1 is of course the smallest integer, then you have 2. So one ratio of small integers clearly is 2 by 1. Other ratios you can think of is 3 by 2, 5 by 4. Now we have chosen these three because they sound good to the ear. Alright. Now with these ratios, let us first of all see an example of the frequencies that are generated given the reference frequency. That is straightforward. So suppose your reference frequency is 100 Hertz. Then the first ratio is 2 by 1. So 100 into 2 by 1 will be 200. That is the upper Shadaj. So we are assuming that our base note, tonic, Shadaj is 100 Hertz. Then the upper Shadaj is 200 Hertz. This sounds good. Then consider 3 by 2. So 100 into 3 by 2 will give you 150 Hertz. And that is your Pancham. Then finally 100 into 5 by 4 will give you 125 Hertz, and that is the Gandhar. So these notes sound quite good. If you later on we will see this, but just now let me mention that if you do these calculations for equally tempered scale, then these frequencies turn out to be slightly different and they do not sound as good to the ear. Of course, you will require a highly trained ear in order to distinguish between the notes of the equally tempered scale and the notes of the diatonic scale. Anyway, let's continue. Now, what we will do is, using these ratios, we will calculate some further ratios. So 3 by 2 multiplied by new ratio is equal to 2 by 1. Using this, we calculate new ratio as 2 by 1 into 2 by 3, that is 4 by 3. So this is another good ratio. Then multiply 4 by 3 by 5 by 4. This is one already available. This is available. We multiply the two and we get a new ratio, that is 5 by 3. Then 3 by 2 into 3 by 2 is 9 by 4. But note that this goes beyond 2. So this is in the upper octave. So if you want to find the equivalent ratio in your middle octave, then what you do is you divide this by 2. So you get the 9 by 4 divided by 2 becomes 9 by 8. Finally, multiply 3 by 2 by 5 by 4 and you get another ratio which is 15 by 8. So let us look at all these ratios that we have generated. 1, 4 by 3, 5 by 3, 9 by 8, 15 by 8, 5 by 4 and 3 by 2. And what we do is we arrange them in the ascending order in order to recognize our notes in the octave. So 1 corresponds to Sa, 9 by 8 is Rishabh, 5 by 4 is Gandhar and so on. Now again remember that Indian notation is relative, so this Sa could be anywhere, whereas Western notation is fixed. So assuming that this corresponds to the C major scale, the corresponding Western notes can be written like this. So C, D, E, F, G, A, B and the upper C. Okay. So now we got these ratios. Using these ratios, we can generate further ratios and finally we'll get 22 Shrutis. Remember, in the equally tempered scale, we have got just 12 notes, whereas in one octave. Whereas in 22 Shruti scale, we'll get 22 notes. So we want to use these notes in order to generate further ratios, which will give us the Shrutis. So let's see how that is done. So first of all, let me give you an overall view. So Shadaj and Pancham are fixed, but using the known ratios, we will generate other ratios, and every note is split into 4 Shrutis. That means you take Rishabh, so you can have Ati Komal and Shuddha and Tivra. Notation for Madhyam is slightly different, so it is written as Shuddha, Ek Shruti, Tivra and Tivratam. Note that 22 Shruti scale is somewhat different than your 12 note scale, because there is nothing like Ati Komal and Komal. You have just Komal and Shuddha. But in 22 Shruti, apart from Shadaj and Pancham, the notes are split into 4 parts. So that's why it's Ati Komal, Shuddha and Tivra. Whereas for Madhyam as slightly different, because we know that the lower ratio starts with Shuddha. So we call it as Shuddha, Ek Shruti, Tivra and Tivratam. Okay. So if you can do our total number of notes now. Rishabh 4, Gandhar 4, Madhyam 4, Dhaivat 4 and Nishat 4. So 5 into 4, that gives you 20 Shrutis. And then you have Shadaj and Pancham which are fixed. So total 22 Shrutis in an octave. Alright. So this is the overall view of 22 Shruti generation. Let us now actually generate the further ratios. So let us start with this diatonic scale that we already have: 1, 9 by 8, 5 by 4 and 4 by 3. So these are our Sa, Re, Ga, Ma. Okay, C, D, E, F. And using these ratios, we find further ratios. So how do we do that? So Rishabh divided by Shadaj is already 9 by 8. Now we calculate Gandhar divided by Rishabh. So that is 9 by 8 divided by 5 by 4. So 5 by 4 into 8 by 9. That is 10 by 9. So this is an extra ratio we have obtained. Then we divide Madhyam by Gandhar. So 4 by 3 divided by 5 by 4. That will give you 16 by 15. So note that starting from our earlier ratios, we have got two more here, 10 by 9 and 16 by 15. Using these, we get further ratios. So new ratios of 16 by 15 and 10 by 9 will be used to calculate additional Shrutis. So 9 by 8 divided by 10 by 9 will give you 81 by 80. And 16 by 15 divided by 81 by 80 will give you 256 by 243. So you got 4 additional ratios now. So you find 16 by 15, 10 by 9, 81 by 80, 256 by 53. So what we are going to do is to arrange these ratios in the ascending order. So let's say we start with Shadaj, that is 1. The next higher one is 256 by 243. You can actually do the floating point calculations and confirm that this is indeed in the ascending order. I'll leave it as an exercise for the viewer. So this 256 by 243, 16 by 15, 10 by 9 and 9 by 8. So these first two are the Komal Rishabh. So you got Ati Komal, that is R1, R2 is Komal, R1 is Shuddha Rishabh and R2 is Tivra Rishabh. Okay, so we have generated 4 notes for R. Now using these ratios and starting, see here, remember we started with a reference note of SA, that was 1, multiplied this by each of these ratios and got our notes. Now to get 4 Gandhas, what we'll do is we'll start with 9 by 8 and multiply by these 4 ratios in order to get the Gandhar notes. So let's see. So these are our basic multipliers: 256 by 243, 16 by 15, 10 by 9 and 9 by 8. So our base note, we start with R2, that is 9 by 8 multiplied by 256 by 243 and we get 32 by 27. You can verify this. Similarly, multiply this by 16 by 15 and you'll get 6 by 5. Multiply by 10 by 9, you'll get 5 by 4, 81 by 64. So you get your Ati Komal Gandhar, Komal Gandhar, Shuddha Gandhar and Tivra Gandhar. Similarly, you can find Shuddha Madhyam, Ek Shruti Madhyam, Tivra Madhyam and Tivratam Madhyam. The technique is similar. In this case, you got, this is the base note, multiply by these 4 ratios in order to get the 4 notes. So this is how you continue and you can get, so since the technique is similar, you can just pause the video and verify yourself, but you will get these further ratios for Dhevar and Nishad. And that completes the calculation for 22 Shrutis. So if you write them in the ascending order, that is how it will look like. Start with Shadaj, Ati Komal Rishabh, Shuddha Rishabh, Tivra Rishabh, and like that. So these are all in the ascending order. And I have a Shruti number I have given. The reason for this is that later on when we study the program for generating 22 Shrutis, this number will be useful. So 1 corresponds to Shadaj, 2 corresponds to Ati Komal Rishabh, 3 corresponds to Komal Rishabh and so on, right up to 22 Shrutis, which corresponds to Tivra Nishad. Alright. Now as far as the chromatic diatonic scale is concerned, it is a subset of this. It contains only, remember, it contains only 12 notes and here you have got 22 Shrutis. So what you do is you go from low to high, but you keep only ratios which are of comparatively small integers. So for example, ratio like 256 by 243 you will discard, 81 by 84. So whichever is the ratio of smaller integers, that you will take. When you do that, you get your chromatic diatonic scale. So that is 1, 16 by 15, 9 by 8, 6 by 5, 5 by 4, 4 by 3 and so on. Okay. So I have shown the Indian notation here and the Western notation here. All right. So now one question we ask is, after doing all this, why do we say that this sounds better? We would like some kind of a demonstration of this. But first what we'll do is, we'll considering a reference frequency of 100 Hertz, we'll calculate all the frequencies in this diatonic scale and also do the calculation for equally tempered scale, see what is the difference and then calculate the percentage difference in order to get some feeling, that is what happens when you are using equally tempered scale compared to that, what frequencies you get, and you will find that the percentage difference is quite small and you will require a trained ear in order to recognize this. An average person probably will not be able to recognize all the differences. Some of the differences he might be able to do, but musicians with highly trained ears are able to do that And that is why Indian classical musicians who can distinguish, they prefer the 22 Shruti scale. This, of course, is a subset of that. All right. So let me show you that table. Table is rather big. Don't be frightened by this. Let's take it column by column. So these are all notes. Okay, diatonic chromatic scale. So we got only 12 notes. So Shadach, Komal Rishabh, Shuddha Rishabh, and so on. These are note numbers. We start with 0 only because remember we had calculated the frequencies by using 2 raised to n by 12. So when this was 0, it corresponded to Shadach. That is why here we have taken 0. Now here the ratios I have already expressed as a ratio of integers, but we express them in the floating point number form here in order to compare them with the diatonic. So these are the diatonic ratios, and these are the diatonic ratios expressed in the floating point number form. Now what we do, assuming a base frequency of 100 Hertz, we calculate the frequencies of all the notes. So these calculations are done here. Basically, this can be easily done in an Excel sheet. So that is what I have done. So you get these calculations. Then these are the frequencies for diatonic. And now for each note, you can see the difference, change in frequency. So you will see that the change in frequency here is just 0.72 Hertz for this Komal Rishabh. 0.72 Hertz only. Whereas this is only 0.25 Hertz. Here this is minus because your equally tempered scale has a slightly higher frequency than diatonic. So diatonic is lower, so it is written as minus. So remember our convention, the way we are writing change in frequency is the difference of tempered scale frequency minus the diatonic frequency. Okay, so, sorry, the other way about. Diatonic frequency minus the tempered scale frequency. So when it is positive, it means that the diatonic frequency is higher. When it's negative, it means it is lower. Okay. So these are the difference in frequency, absolute numbers in floating point. Now, if you do percentage change, this is the percentage change. So 0, 0.68, 0.22, 0.91. Here it's somewhat higher. So probably an average ear with some difficulty will be able to recognize the difference. Here Pancham, you can see here for the Pancham it's just 0.11, but trained musicians are able to recognize between this Pancham and the tempered scale Pancham. Okay, so this calculation was shown to you in order to give you an idea that the frequencies are really quite close, and that is the reason, although tempered scale is not the best scale from the viewpoint of quality, it is still used worldwide because most of the average persons anyway will not be able to distinguish. That's why the equally tempered scale is used worldwide. All right, let us now see how to write the program for generating note 22 function. Now, first of all, note that the output variables I have added t here because later on I wanted to plot certain notes as a function of time. That is why this t is added here. Note that you can add, instead of t, you can add frequency also if you want frequency as the output. But right now I have added t. All right. The other input variables are same, that is S, N, D and F. We have already described this. But now the difference in the note 22 function and the other previous function that we have studied, the main difference is in the calculation of this capital N. There we had a formula available, so we could calculate by using 2 raised to n by 12. Now the ratio is not constant. We do not have a formula available. So what we do is we use the lookup table method. So in fact we list all the ratios. So since there are 22 ratios and difficult to fit them into a single line to see it easily, what I have done is I have split it into number of vectors and finally combined all the vectors in order to get the final vector of 26 Shrutis. So that is your N6. Remember the one of the earlier tables, we had listed all the 22 Shrutis, and this vector corresponds to those ratios. So now what you do, basically you have to provide the appropriate index. So your main program, remember, this n will now have a value right from 1 to 22. Whereas remember, for the equally tempered scale, this small n had a value for one octave going from 0 to 11. Whereas here it will go from 1 to 22. So whichever note you want to generate in the main program, this n has to be supplied. All right. This is of course for the, so our basic reference frequency is in the Mandra Saptak, and here this is the Madhya Saptak and this is the Tar Saptak. This we have already explained. It was the calculation of capital N that is different in this case. The rest is similar. So you calculate your F1, then you define your T vector. Then for reasons we have discussed earlier, we require equal function. Then we generate the note, okay, and that is returned by using the variable tone here. So that is your note 22 function. Now what we are going to do is to demonstrate to you the difference in the diatonic scale or the 22 Shruti scale and the equally tempered scale by using chords. So chords is something we have not discussed so far, But before that, let me just point out to you that our tempered note function also we have made a slight change. We have added the variable t also here because later on we want to plot t versus the chord that we will be talking about. So other rest of it is similar. Tempered note function. All right. So let us now see how the chords are to be generated. So what we are going to do is to first generate the chords. Now what are chords? We have not discussed them before, but I'll explain them in simple term. See, on a physical instrument, a musician, when he plays a chord, what he will do is he will press many keys together. For example, he will press Shadaj, Gandhar and Pancham, all the three together. When he presses them together, what happens? The three sounds will come out of the keyboard instrument. They get added in the air before they reach the air. So when we want to generate a chord digitally, what we do is we generate three different notes. So Shadaj, Gandhar and Pancham, and simply add them. And then what we are going, the rest of the program, again the concepts we have already discussed before. So you can simply pause the video at this point and go through the program, or maybe if required you can refer to the earlier videos that in which I have explained all these kind of statements. But main point is that you generate a chord using tempered notes, and then you also generate a chord using diatonic notes, and then we would like to see the difference. So we'll see the difference in two ways. One is graphical and the other is audio. So let us see that. Now if you plot the chord as a function of time, if you look at the tempered chord, you see that you get some kind of a cyclic variation in the amplitude. This is a kind of a beat that is being generated. Whereas if you look at the diatonic chord, you can see it is quite smooth. There is no cyclic variation in the amplitude. So the two chords sound slightly different. Again, you'll require a good ear, trained ear to recognize, but possibly even an average person will be able to recognize this. So let me play this chord. This is tempered. Probably you saw some variation in the amplitude. Again, let me play that. Okay. Now let us play this. Let me play that again. You can see that there is no beat effect that is present here. Whereas in this, okay. So that is about chords. Let me give you another demo. So suppose we have a vector which contains only two notes, let's say Pancham and Komal Nishad. So tempered, it sounds like this. Each is of, I think, 1 or 2 seconds duration. We'll see that. So Pancham followed by Komal Nishad. That is tempered. Let's see this diatonic. The trained ears certainly will be able to know the difference. So in this session, we have seen how the 22 Shrutis evolved and what is the difference in terms of audio and in terms of graph. And that's all in this session.